Okay, welcome back, folks. We're in section 7.4, and we're looking at the trigonometric form of complex numbers. So now instead of the x and y axis, we are going to have the real axis, which is the x-axis, and the imaginary axis, or IM, which is the y-axis, represents the y-axis. So here is a complex number, 5 plus 3i. 5 would be the real value, 3i would be the imaginary value. So if we were plotting that point, or we were plotting that on our graph, we would go over 5 on the real axis and up 3 on the imaginary axis. And for these, so again, we would have our value of a, which is 5. Let's call that a. And we would have our value of bi, or our imaginary value, which is 3i. So on the imaginary axis, there's always an I with it. And then what we would normally think of as our radius, let's make that a different color, is what we call z. So z is the value of a complex number, okay? Or the distance from the origin to that point represented by the complex number. So just like we could do with real numbers, when we had x and y coordinates, we can take the square root of a squared plus b squared, excuse me, and that's going to give us the value of z, or the distance from the origin to that point. So if we did that for 5 plus 3i, z would be equal to the square root of 5 squared plus 3 squared. So 5 squared is 25, 3 squared is 9. So we get radical 34. So in this example here, z is equal to radical 34. Okay, so you're going to be asked to find the value of the complex number or find the value of z. And all you're going to do, again, is take the a value and the b value. So again, this is in the form of a plus bi. Then we're going to find that by finding the distance from the origin to that point. Okay. Now, sometimes you may have 0 in one of the two places. So you can see up here in this example, let me move that a little bit so we can see it, or so I can see it on my screen. So we have z equals negative 5i. So that's the same as 0 minus 5i. So if we're finding the value of that, we would take the square root of 0 squared and negative 5 squared. So that's just the square root of 25. So in this case, the value is just 5. Okay. So to put this in trig form, again, we know that r, the radius, or the distance along the ray, or the hypotenuse, is equal to the square root of a squared plus b squared. We know we can find the angle by taking the tangent of the angle equals b over a, and we can do inverse tangent. Well, that also means the same thing we've used before. Cosine is equal to a over r, sine is equal to b over r, which gives us these values. A is r times the cosine of theta, and b is r times the sine of theta. So if we know that, move this down a little bit because I think I'm covering something up, we can substitute those in. So our r cosine theta goes here in place of a, our sine theta goes in place of b, but we still have this I. So the I comes over here. So our a plus bi is complex form. In trig form, it's r times the cosine of theta plus I times the sine of theta. Now, there is a shorthand for that, and let me give that to you over here. And that would be written as r cis theta. So C is for cosine, I is the I value, S is for sine. So we can just write it out shortly instead of writing all that out every time. So you'll see it written like this. So you might see, for instance, you might see a value that is 5 CIS of pi over 6. That would be the shorthand method of that. Okay. All right, so the first thing they're going to ask you to do besides finding the value of z is to write a number in from trig form to complex form or from complex form to trig form. So we're writing a complex number in trig form. So first we need to find the value of z or r, or it's technically the absolute value of z. So in this case, r would be equal to the square root of 1 squared plus radical 3 squared. Well, it's technically negative radical 3, but it's going to come out positive anyway. So 1 squared is 1, radical 3 squared is 3. So we get 4, and the square root of 4 is 2. Okay? So we need to find r. So let me write the formula up here again. It's r cis theta, or r times the cosine of theta plus I times the sine of theta. Oh, left out my I. Okay, so you can write it in any one of these. Either one is fine. You want to use the shorthand. So we need to find out what theta is. We know what r is. Got that. So theta, again, we're going to use tangent. So the inverse tangent of b over a. So b is negative radical 3 over a, which is 1. And if we do that, we're going to get negative 60 degrees, which is 300 degrees. Okay. So make sure you pay attention to what quadrant you are in. And with these problems, make sure you pay attention to how they want you to answer it. It may ask you to answer it in radians. It may ask you to answer it in degrees. Okay. So if you go to put one of these into WebAssign and for some reason it's not taking degrees, put it in radians. Okay. Just write it in different form. So we got our theta, which is 300. We got our value for r, which is 2. So z in this case would be equal to 2 times the, I'll write it all out, cosine of 300 degrees plus I times the sine of 300 degrees. And again, you could write that as 2 cis 300 degrees. Okay, so that's going from complex to trig form. Now we're going to do the exact opposite. We're going to go from trig form to complex, or what they call standard form. So first thing we're going to do is we're going to expand our shorthand. So 6 cis 240 is the same thing as 6 times the cosine of 240. Let's put that in parentheses, plus I times the sine of 240. And if we distribute the 6, then this would be 6 cosine 240 plus I sine 240. Whoops, plus 6I 6 sine 240. There we go. I did say distribute the 6. Okay, so the cosine of 240 is negative 1/2. The sine of 240 is negative radical 3 over 2. So if we multiply these both by 6, 6 times negative 1/2 is negative 3. And we're going to get a negative here because 6 times negative, so it's going to be minus I times 6 times radical 3 is 3 radical 3. So in trig form, we get negative 3 minus I 3 radical 3. Or we could write that as 3I radical 3. Either one would be fine. Okay. All right, so the other thing we're going to do in this section is we're going to multiply two complex numbers together. In the next section, we're going to look at taking the square root of complex numbers. In this section, we're going to look at, actually, we're going to look at multiplying and dividing complex numbers. And both those formulas are on your formula sheet. And as I've mentioned before for this chapter, almost every single thing we do, there's a formula on the formula sheet. So it's pretty much following the formula sheet and plugging in numbers, okay? So we're finding the product of two complex numbers. Here's the formula. So we're going to take R1, the radius from the first complex number, times R2, the radius from the second complex number, times the CIS of theta plus theta. Okay? So for each one of these, we need to know what R is, and we need to know what theta is. Okay? So let's figure that out first. So let's start with the first one. So for the first one, well, it's R sub 1 is equal to the square root of negative 1 squared plus negative radical 3 squared. We're getting those numbers right here from our first complex number. Okay, so if we simplify all that and take the square root, this ends up being the square root of 4, which is 2. For our second complex number, so R sub 2, that is the square root of negative radical 3 squared plus negative 1 squared. So really, the same thing. It equals 2 as well. Okay. And for theta sub 1, so this one, theta is going to equal the inverse tangent of b over a, so radical 3 over 1. The negatives are going to cancel out. And that's going to give us 60 degrees. And over here, theta sub 2 is going to equal the inverse tangent of, again, b over a, so negative 1 over negative radical 3. And if we do that correctly, it's going to give us 30 degrees. Now, here's the thing, you got to pay attention. Both of these are negative, which means z sub 1 is in quadrant 3. Both of these are negative as well, which means z sub 2 is in quadrant 3. So really, our angle isn't 60, our angle is 180 plus 60, which would be 240 degrees. And this one would not be 30, it would be 180 plus 30, which would be 210 degrees. So we have our two values for R, we have our two angles. So the product, Z1 times Z2, is going to be equal to 2 times 2 times the CIS of 240 plus 210. And 2 times 2 is 4, so we have 4 CIS. 240 plus 210 is 450. Well, we need an angle between 0 and 360. So if we subtract 360 from that 450, then we get 90 degrees. Whoops. Okay. Now, if you notice, technically that's our answer, but that's in trig form. The problem wants our answer in standard form. So we need to convert this, so we basically need to expand it and figure out what the CIS of 90 is. So we got 4 times the cosine of 90 plus I times the sine of 90. So cosine of 90 is 0. Sine of 90 is 1, so we're left with 4 times 0 plus I times 1. 4 times 0 is 0, 4 times 1i is 4i. So in standard form, this is equal, the product of these two is equal to 4i. Okay. All right, again, division, the formula is in your formula sheet. So here is the formula here. This time we're going to take R1 divided by R2 and the CIS of theta minus theta. Now, the nice thing here, if you look at the two values, we know the R values for each one because they're in trig form. So Z1, R is, make a little table up here. For Z1, R is equal to 32 and theta is equal to 30. For Z2, R is equal to 4 and theta is equal to 150. So this one's pretty simple. Z1 divided by Z2 is 32 over 4 times the CIS of 30 minus 150. And again, they want the answer in standard form. So 32 divided by 4 is 8. And that would be 8 times the CIS of 30 minus 150 is negative 120. So you could put it in your calculators that way. I don't have this one all worked out in my notes, so I'm going to have to plug it in my calculator. So cosine of negative 120 is negative 1/2. Let's expand this out first. So this would be 8 cosine negative 120 plus I sine negative 120. So again, the cosine of negative 120 is negative 1/2. The sine of negative 120 is negative radical 3 over 2. So if we multiply this all out, 8 times 1/2 is negative 4, or negative 1/2. 8 times I negative radical 3 over 2 is going to be, let me stay a minus. Let's see, that's going to be 4I radical 3. So in standard form, here is our quotient after we divide the two numbers. So if they give it to you in trig form, remember trig form is R, write that over here, RCIS theta. So we know what R is. We know what theta is. We don't have to do any calculations. We can just plug them in to our formula. In the previous one we were multiplying, we had it, both of them, in trig, or sorry, in standard form. So we had to change it to trig form in order to plug it in, or we had to find R and we had to find theta and then plug it into our equation or our formula, okay? So make sure you pay attention to that, whether they give it to you in trig form and you don't need to do calculations, just plug in numbers, or they don't and you need to plug in numbers. And again, pay attention to whether they want the answer in standard form, which is complex form, or trig form, okay? All right, that's it for section 4. Is that 4? Yeah, that's 4. Okay. Section 5 is going to be some square roots, which gets, it's not really too difficult. It's just kind of lengthy because there's multiple answers. And then we've got the one section in chapter 8. So I'll see you next time. And don't forget to email or message me through WebAssign or sign in for office hours if you need extra help.